Hey folks, thank you for joining in. Let me just check if everything is working all right. Just give me a second. I just wanted to see if everything is working all right. Hey folks, thank you for joining in. Let me just check if everything is working all. Yeah, so I can hear myself in the live feed, so I'm assuming everything is working for everyone. I'm also looking out at the chat window so that I can take as many questions as we can in today's session. So yeah, so let's get going. Or since it's exactly 10, let's wait for a couple of minutes. I'll answer a few questions. Hey, thank you, folks. Hi, everyone. Thank you for joining in. And I'll just wait on the live chat here, and let's wait for everyone to join in. There are a couple of points that I noted down that I thought I'll cover, and these are mostly about general strategies for interviews, for freshers, for experienced folks with different types of experience, folks from different engineering backgrounds, different disciplines, again, different experience levels, different companies, different roles, etc. I've made some notes. I'll try to cover as much of this as possible in this live session, but I'll also try and shed some light on what depth, because I see this question asked by many people. Should I remember formulae? Certainly, why not? So again, depends on the company you're interviewing for, depending on the team that you're interviewing for. What most people are looking for is not whether you remember a formula by heart. I don't care if you remember Bayes' theorem by heart or not, but do you know what Bayes' theorem actually is? Even there are a lot of formulae that I don't remember. For example, if you suddenly ask me, okay, what is the primal and dual of SVM? I don't remember it by heart, but if you give me 2 to 5 minutes, I can actually derive it. Okay. Similarly, if you ask me any formula like that, right? Of course, I know some basic formula like what is entropy. These are some basic stuff that I do know. But if you ask me to derive, if you ask me some slightly complex formula, I may not remember it by heart, but I know the concepts behind it that I can derive it in like 2 to 5 minutes. And that's what is important. Actually, I'm terrible at remembering formulae. But formulas are important because they tell you how things behave. If you don't know the Bayes theorem, right, I can't expect you to know how naive Bayes works, right? Without knowing Bayes theorem, how can I assume that you understand naive Bayes? If you can't explain me what is the loss function of logistic regression, you can't understand how logistic regression behaves when you have outliers, or how logistic regression behaves when there are some anomalies in the data, how it behaves when you have imbalanced data sets. All of that can be derived very easily and very ingeniously from the formulae. So actually, just like many of you, I'm terrible at remembering formulae, but I can derive formulae from first principles. And that's what we've done in the course also, right? If you realize, in the course videos, except for a very few formulae, most of them we have tried to derive from very basic principles in geometry and algebra. Okay, your 12th class mathematics is all you need to derive most of machine learning formulae. Actually, of course, there are some additional stuff that you'll learn, but we've discussed most of them in the course. So instead of trying to remember formulae, remember how they're arrived at and the intuition behind it, either geometric or mathematical, right? That's super duper important. So I'll again, to be honest with you, I'll try to focus this discussion only on how to prepare for interviews. I'll try to avoid taking questions from the whole spectrum of topics, because that way I'll not be able to cover the topics that I want to cover and address questions from students who are here especially for that topic. So instead of trying to answer questions across the whole breadth and length of machine learning, deep learning, I'll try to narrowly focus on how to prepare for interviews based on your background. Okay, so I see a lot of questions here, and since we waited for a few minutes, I think a ton of you have joined. Thanks for joining in, and a very good morning to everyone who has joined in. So let's get started. Anyway, I'll keep a lookout for all the comments in the chat session. And before we get, so the focus of today's discussion, again, I've just written some notes here, and I'll try to discuss as many points as possible. So first and foremost, okay, first let me give you an overview. I'll also answer questions as we go forward, right? First, let me give you an overview, because in this overview, almost 80 to 90% of your questions will be covered. Like some of you are asking me that you have computer science experience or non-computer science experience. How can you transition to machine learning roles? I'll answer all of that. So let me give you a broad overview. I'll keep taking questions in between. I'll try to make it interesting. There's also a very good question on if I'm an MBA, how do I transition to machine learning roles? I have that covered in my notes, right? So let's go step by step. First and foremost, here I'm assuming that you know some machine learning, you know some basic programming before you go to a machine learning interview, right? So we'll focus on how, I'm assuming that you know some machine learning, deep learning, some mathematics, some programming and things like that. Without that, going for a machine learning interview is useless. It's like going to a software engineering interview without knowing what programming is. It's useless. So don't even apply to machine learning roles without knowing decent amount of machine learning. And what is decent? We'll discuss that through the rest of this session. So first and foremost, interviews come in all shapes and sizes. I've seen interviews in the hundreds of interviews that I've done just at Amazon itself. I've seen interviews come in tons of shape, and the hundreds of students that we have placed as part of Applied AI course, based on the feedback that our students have given in almost 300 plus companies now, we have seen a huge spectrum of interviews, and I mean, there is a huge variety, right? But we can break that variety into some small sections. I'm not saying that I can cover every type of interview, right? Because there are as many interviews as there are interviewers. And very importantly, since data science and machine learning is a more recent type of job, unlike software engineers, because software engineer as a job has been there for the last 30 years, right? Since the early 90s, this job of a software engineer has been there. So software engineer interviews are much more structured because there is a structure that is associated with. For example, for software engineer interviews, if you're interviewing at a services company, especially as a fresher, you're typically asked basic questions in programming. You're asked to write some simple programming questions like implement a queue, implement a stack, right? Or you're asked basically, if it's a services company, typically, or you're given a simple set of problems which require some basic data structures, basic algorithms, and you can implement it. That's one type of question that you're asked at Infosys, TCS, all these companies. Also, you might be asked some basics of databases like SQL queries. Again, this is all very basic stuff that will be asked. Again, but if you go to a product-based company like Amazon or Google, the level of questions will increase. But typically, most of the questions are again from data structures, algorithms. Some companies some companies also may have aptitude rounds depending on the company. So there is a much more neat structure around software engineer interviews. But for machine learning and data science, it's not still very structured. Okay, it's still there is still a lot of gaps there is no structure because this role is also still evolving. But over the last decade that I've been interviewing candidates, I've seen some structure evolve. Okay, it's not perfect. Again, I'm not saying that every interview you may attend in your life will fall into this structure, but there is some structure here. So we'll try and cover the most type of interviews here. So let's go here. Okay, typically, whether you're a fresher or an experienced candidate with again, first we'll see what all typical rounds you'll encounter, right? Typically, 99% you'll have a programming round. Again, the complexity of the programming round will depend on the company, will depend on the team, will depend on your background. Okay, but broadly speaking, you'll have a programming round of some sort. Obviously, this programming round may test anything from basic programming skills or your SQL, especially because data scientists and machine learning engineers end up using a lot of data sources like databases, data warehouses, etc. SQL is something that is often asked. If you say, I don't know SQL, I've never studied SQL, they'll say that's okay. Again, it depends on your background. Suppose if you're a mathematics PhD or a physics PhD, right? Or if you're a civil engineer who has never studied, or if you're a mechanical engineer who has never studied SQL, SQL is not expected as much out of you. But if you're a computer science engineer or if you're a working professional who worked in software engineering for a few years, then you're expected to know SQL, right? So programming and SQL also, again, we'll see what types of questions are asked based on the teams and based on the companies a little while. But typically there is 1 or 2 rounds of programming. And of course, if you go to a services company, the level of questions is certainly easier. They might ask you simple questions like, okay, let's take a few questions, right? Very simple questions. You are given 2 sorted lists, right? Or 2 sorted arrays, and you have to find the median of these 2 arrays. Median, not the mean. The median of these 2 arrays, which is again very simple problem because these arrays are already sorted. This is literally, if you write code in Python, this is literally 10 lines of code, right? So these are very simple problems where they're just testing if you can program in a programming language using loops. That's all they're trying to test. They're not trying to test whether you know some advanced data structures or some advanced algorithms, time complexity, space complexity, all of that. Okay, they're not testing if you know KD trees, all these advanced data structures. They're asking some very, very basic stuff. Okay, again, the first, maybe you could have 1 or 2 rounds of programming. Again, the number of programming rounds also depends on the team. Okay, first let me give you an overview of all the types of interviews that you could encounter. One is programming. Programming could have programming some data structures and algorithms, again, depending on the company. You could also have SQL in your interviews. Okay, we have covered all the important topics as part of our course anyway. I'll come to what we have covered in the course a little later. The second type of thing, which is very, very important, is called real world problem solving rounds. These are some of the best interviews actually. And that's because there is a reason behind it. And that's because you might learn all the theory under the sun, but if you cannot solve a real world problem, what's the use of all of that? And these problems are more focused on experienced folks. Suppose if you're a software engineer with 4 years experience, you would have learned the ability to solve real world problems in these 4 years, right? So typically then you're asked a problem like this. Okay, here is a real world problem. For example, they may say, okay, we are a music company. Okay, let's say you're working with Savan, okay, which is a music streaming company in India. So, or let's take Spotify or any of these companies, right? Music streaming companies like Spotify or Savan. They might say, how do you recommend new songs to people? Very simple question, very real world question. Then they expect you to work out the solution from what type of data you collect to how do you productionize the model. So these interviews typically are very open-ended. They'll give you a problem, a real world problem. Most likely interviewers give you problems that they are working on themselves because they understand that problem very well, right? So I have often asked in my interviews people, I've explained them a small module of the problem that I'm solving currently, and I ask them, how do you tackle this? Because as an interviewer, this gives me a lot of insight into how you think, how you will be as a colleague if I hire you, right? These are extremely valuable interviews, especially for experienced folks. If you're a fresher, you could give some textbook solution and people may say, okay, this person does not have a lot of experience, so that's okay. But even if you're an experienced software engineer, people expect you to have that acumen, to have that insight on how real world problems are solved in the industry and be able to translate that, right? So real world problem solving interviews are superb. And that's actually, we often ask our students to build a strong portfolio of at least 2 projects, preferably up to 5 projects. That's because when you have a portfolio of projects and when you take it to the interviewer tends to focus a lot of their time on the problems you've solved. Because if you cannot explain me the problem that you claim that you have solved thoroughly, then what will you solve a new problem? So that's why portfolio of projects is super duper important. We emphasize so much on it as part of our course and in general also. You should always solve 2 to 5 problems thoroughly, end to end. You should try to solve these problems end to end. Everything from obtaining data, cleaning data, pre-processing data, building the whole models, coming up with the right metrics to productionizing these models. That whole spectrum you should be able to solve. At least 2 to 5 problems based on your domain. For example, somebody is asking here that he comes from bioinformatics background. If you're coming from bioinformatics background, then obviously you should solve bioinformatics problems. There are tons of bioinformatics problems which use machine learning and data science. If you come from banking IT domain, let's suppose imagine you worked at a bank as a full-time employee or as a consultant, then you need to understand. Then Hi, folks. I'm back. Let me just check if everything is working. Sorry, I had a power cut. Extremely sorry for that. And
Hi, folks. I'm back.
Sorry. Somebody says I'm on breakfast. It's been a long time that I had a breakfast. I typically wake up at 4:35. So I finished my breakfast by 6 a.m. Anyway, so back to our discussion. Sorry, I had a power cut. The summer is still not over in Hyderabad, and it takes a few minutes for my inverter and my Wi-Fi to get started again. Sorry, folks. Sorry for that. Anyway, back to the discussion. I hope everybody is back here, right? It's working, right, for everyone? Just refresh the screen and everything should work, because I just joined back. It immediately reconnected me back. Power cut prediction. Why do you want to do that? You can just ask the electricity department and they'll tell you when the power cut is. Anyway, sorry for this goof up. Yeah, I hope it's working fine. Yeah, so where were we? We were discussing about the real world problem solving part, right? So unfortunately, if the power gets cut again, I'll just join on my 4G in a few minutes. But typically what happens at my residence is the inverter kicks in within a few minutes, right? So just stay online for about a couple of minutes and we'll be back here. Okay. So back to the discussion. So we were talking about real world problem solving questions, and these are some of my favorite questions because they help me understand as an interviewer how you will be as a candidate. That's very important for me, right? Because it'll help me understand how you will be as not just a candidate but as a colleague. If you join my team and if we are working on the problem together, how does your thought process, how can you think? That's where real world problem solving is super duper important round, that I think almost every company across the spectrum, from the smallest of companies to the world's best companies, they typically end up having one of these real world problems. And these real world problems can be picked in two ways. Number one, the interviewer could choose the problem that they are solving currently and give it to you as an open-ended problem to see how you think. Number one. Number two is they could also ask you a problem that you have solved in the most recent past. Again, I've seen this in hundreds of interviews, right? If you try to fool the interviewer, if the interviewer is even half smart, he can detect it. I've seen candidates who claim that they've done this, they've done that. I say, okay, great. Let's dive into it. So I start asking some of the questions that only a person who has actually solved it can answer, and they get caught. We immediately cut the call and say, thank you. We're not interested in you, right? So please don't try to cheat an interviewer, because if he's even half smart, you'll get caught. Only if you have solved a problem really, only then explain that problem to the interviewer. That's very, very important, because interviewers, especially people who have tons of experience interviewing, will catch you in like no time. I've done this. I've seen a lot of candidates who claim they've built that, but when you go slightly deep where real world stuff matters, they'll get caught. So please don't bluff an interviewer. But most importantly, solve a portfolio of projects, at least 2 projects, end to end. So because that gives the interviewer a chance to dive into problems that you solved. Again, in an interview, as much control as the interviewer has, there is equal amount. Actually, I would say there is more amount of control in the interview by the candidate. A candidate can control the interview much more than an interviewer. For example, I've done this many times. I've seen a lot of smart candidates control the interview. They take the interview in the direction that they are comfortable in, instead of the direction that the interviewer is comfortable in. That way, they can actually showcase their strengths, right? You don't want to be stuck in an area of machine learning or on a problem that you're not comfortable in, because that way you're not able to showcase your skills. So a good candidate knows how to take the interview, how to guide the interview in the direction that he can perform well in. That's very, very important, right? So if you have a portfolio of projects, the portfolio of projects are like good catch points for the interviewer to pick on. For example, if you come to me for an interview and if you say, I've solved this problem in recommender systems, I'm very good. Okay, you've solved this problem, right? So let's dive into recommender systems now, because that gives me a hook into one topic which I can dive into deeply. So it's very, very important you have a portfolio of projects for the real world problem solving rounds. Then, so this is the second round. First is programming, second is real world problem solving rounds. The third one is machine learning breadth. Machine learning breadth rounds. Again, many people may not use this term called machine learning breadth, but typically there are rounds wherein they try to test a wide spectrum of algorithms that you know. Okay, they try to test if you know, let's say, if you know these 10 or 20 most widely used algorithms or not. So those are called as breadth rounds. Why are they called breadth? Because they're trying to test or understand the breadth of knowledge you have. And here again, every person has a different breadth of knowledge. It is impossible for any single person to have the whole breadth of topics unless you've been doing machine learning for 2 to 3 decades. To be honest with you, there are some areas of machine learning where I'm not superb at. Okay, where I'm not, frankly speaking, that I'm not an expert at, right? Because I've not worked in those areas, or after graduate school, I've not studied them immensely, right? So the breadth of knowledge gives the interviewer a knowledge. So in the breadth round, right, they might ask you one question about one of the major techniques. And in an interview, if you don't know a technique, for example, somebody asks you about, somebody asks you about conditional random fields. Let's say, okay. So if somebody, which is a topic in graphical models in machine learning, if somebody asks you about conditional random fields, okay, you can quietly say, I have heard of conditional random fields, that this is what they do, but I don't know exactly in depth how they're used, or you can say, I know where they're used, but I don't know the exact mathematics behind it. It is perfectly all right to say, I don't know CRFs. It's perfectly all right, because interviewers generally don't expect you to know everything, right? Because the interviewer himself most likely doesn't know everything, right? This is true with me as an interviewer. I've done hundreds of interviews. There are some topics in machine learning and deep learning that I'm not good at. And if an interviewer gives me a solution based on these techniques, I'll clearly tell him, sorry, dude, I'm not an expert in this area. Can we try something else? And that honesty really pays off, trust me, right? So in breadth rounds, try and answer. They'll try to test your breadth of knowledge. They'll go from simple algorithms like naive Bayes, k-nearest neighbor, logistic regression, SVMs, random forest, GBDTs, the whole spectrum of techniques. They might pick one small question from each of them to see if you know all of the most important techniques or not. And if you don't know something, it's perfectly okay to say so, because they're only trying to test or trying to understand what you know. Okay, so those are called machine learning breadth rounds. Then very importantly, there is something called as a machine learning depth round. These are very important because you may not know every technique. Okay, that's perfectly valid. But in machine learning depth round, you're asked to pick a few techniques that you're very comfortable with or that you've used in the recent past. Okay, for example, let's assume I have used SVMs in the last 1 year in some real world project. Then I'm expected to know SVMs very well because I've actually used it to solve a problem, right? As part of my portfolio of projects or as part of the experiments that I've been doing. So when they ask you, tell me a technique, this is something that I've done a lot, right? In my own interviews. I've seen a lot of people also do this as interviewers. They'll ask you to pick a technique that you're most comfortable with, or they'll ask questions from the technique that you claim that you have used in your portfolio of projects or in your most recent work. Suppose if I've used SVMs, I'll say, okay, let's dive into SVMs. I'll ask you every nook and corner of SVM. Every nook and corner I'll ask you, right? Because if you have actually used SVM, I assume that you have understood it thoroughly, right? Again, you need not be an expert in all the techniques, but those techniques that you claim that you have used recently or the techniques that you claim you're good at, you better be good at them. Because that tells me whether you're thorough with learning a concept and using that concept or not. If you tell me that you're good at SVM, but if you can't write me the hinge loss interpretation of SVM, I'm like, come on, dude. I mean, this is not accepted. Or if you can't tell me how support vectors are used, right? Or if you can't tell me, if you can't write down the optimization problem of SVM, right? Again, you just telling me the theory is not sufficient. You have to explain me how kernelization is useful. How do you design the right kernel? How do you tune the parameters of the right kernel? These are all important questions. If you say that I have actually used SVMs or I'm good at SVMs, I expect you to answer these questions, right? Again, as part of our course videos, we try to cover as much as possible. Again, no single course in the universe can cover everything. Just like no single textbook can cover everything, right? So we try to cover as much as possible as part of our coursework. Again, we give additional links also. So depth rounds, you have to be very careful. And my suggestion is, if you're building a portfolio of projects, those techniques that you've used in your case study or in your projects or portfolio of projects, try to dive deep into them and understand every nook and corner. Okay, because the depth rounds tell me how deep is your understanding of a subset of concepts. Okay, then very importantly, so these are the 4 types of interviews, and there is a 5th type of interview. This is your mathematics foundations. Lot of people mess up this interview. People say, okay, I know, again, we have done interviews at some of the world's best universities. Some of my friends who are also our mentors and our advisors at Applied AI course have done, between all the advisors and everybody, we might have done thousands of interviews, right? We have seen candidates who can tell everything about every algorithm, but if you ask them something in basic linear algebra or something in basic probability, like we give them a simple problem in Bayes' theorem, we expect them to solve it. You just have to apply Bayes' theorem and solve that problem. Some people can't do that, right? That shows that your understanding is superficial because your mathematical foundations are weak. And why is this round important for an interviewer? Because new techniques will keep evolving. There is no staticness in machine learning and deep learning. Every week, every month, there are a new set of techniques that come, right? So that is a problem, right? So if you do not want to fall back, if you don't want to fail in that, right? So the most important aspect here is again, the interviewer is trying to test whether you can cope up with new techniques that evolve. For that, your foundational mathematics is important. Can you write the equation of a line? Can you compute the distance of a point from a line? Without that, how do you understand logistic regression? How do you understand support vector machines, right? Can you understand what is entropy, right? When does something have maximum entropy or minimum entropy? These are basic foundations, right? Without that, you can't build a random forest or even a decision tree. Similarly, basic minima, maxima type of stuff, basic calculus. How does derivative change when you reach a minima, right? These are very basic stuff. If you can't answer these very, very basic things, mathematical foundations, right? These are typically your matrix algebra or linear algebra, your probability, basics in calculus. These are the three most important topics for machine learning: probability and statistics, linear algebra, and calculus. Again, calculus, you don't have to be an expert in integrating using tons of methods. The most important calculus for machine learning is differentiation. Again, you don't have to be an expert in second order differential equations, all of that. The calculus that is required, which is the maxima minima computation, which is used in stochastic gradient descent algorithms, that part you have to be pretty good at. You don't have to be an expert in second order differential. Those are not required because we don't use them day to day in machine learning. Of course, if you know second order differential equations, that's great, right? But it's not important on a day to day basis, right? So that's very important. Again, somebody is asking here that, again, most interviewers, I've seen some interviewers also. This is based on the feedback that we got from our students who attended interviews and who got placed. Some interviews just ask you a formula, right? They expect you to remember a formula. Just be truthful to them and say, I don't remember the formula, but if you give me 2 to 3 minutes, I can derive it for you. Actually, that's what is important, right? Or I can explain you how this formula works, right? And that is very, very important. Remembering by heart is useless, trust me, because what you remember today, 1 year down the line, you'll forget. But if you know how things are arrived at, that skill stays with you for a lifetime, right? That's why as part of our course, we try to derive everything from first principles, from what is the equation of a line, what is the distance of a point to a line, right? And then slowly work out. Then we give justifications on why we are doing this, why we are not doing it, right? So that is very, very important. Again, somebody saying, is learning unsupervised learning important? Why not? See, if you go for a machine learning interview, the basic set of techniques you have to know. If you say, I don't know what K means is, come on, that's a joke. Okay, if you don't know what is agglomerative clustering or basically hierarchical clustering, that's a joke. It's considered one of the basic concepts, right? If you say, I don't know some advanced tech, suppose if you say, I don't know DBSCAN, okay, that's okay, because there are some good machine learning engineers or some good folks who may not know DBSCAN, but they can pick it up. But if you don't know basic techniques, that's a red flag for me. If you don't know some advanced concept, if you don't know something